Question number 12. Three machines, A, B, and C, are used to produce a large quantity of identical parts at a factory. Machine A produces 60% of the parts, while machine B and C produce 30% and 10% of the parts respectively. Historical records indicate that 10% of the parts produced by machine A are defective, compared with 30% for machine B and 40% for machine C. Suppose we randomly select a part produced at the factory. Okay. So part A, find the probability that this randomly selected part is defective. And then part B, if the part is found to be defective, what's the probability that it was produced by machine B? All right, so this is the kind of a classical problem where you'd want to use a tree diagram. All right, let's make sure that we give ourselves plenty of space. So the part could come from any of the three machines, machine A, machine B, or machine C. And we know that 60% of the parts come from machine A, 30% from machine B, 10% from machine C. Okay. We also know that all three machines at some time or another produce defective parts. Okay, so I'll use D for defective and DC for not defective. D, DC, D, DC. Okay, historical records, 10% of machine A parts are defective. So 10% defective, 90% perfectly fine. At machine B, it's 30% defective, so that would be 70% that are fine. And then for the last machine, 40% defective, so 60% working just fine. All right, so there are 6 possible outcomes when we select a random part. Maybe we get a part from machine A and it's defective. Maybe we get a part from machine A and it's not defective. I don't want to have to write this over and over again, so let's just copy and paste. Okay, so the third outcome is machine B and defective. The fourth outcome is machine B not defective. The fifth outcome is machine C and defective. And then the last outcome is machine C and not defective. All right, to figure out these final probabilities, we're just going to be multiplying the probabilities along the branches. Remember, and usually indicates that we multiply. All right, so 60% times 10% is 6%. 60% times 90% is 54%. 30% times 30% is 9%. 30% times 70%, that's 21%. 10% times 40% is 4%. 10% times 60% is 6%. All right, now, for completeness sake, let's make sure that everything here adds up to 1. Okay, 6 plus 54 plus 9 plus 21 plus 4 plus 6 adds up to 100%. All right, so I'm feeling, pretty good about all the calculations I've done so far. Let's see how we can now use this to find the answer to part A. So, what's the probability that the part is defective? Okay, so the probability of a defective part, well, hey, I know that this outcome, and that outcome all lead to defective parts. So let's just add those probabilities together. Okay, 6% plus 9% plus 4%, that's 19%. All right, so that was part A. Okay, part B says if the part is inspected and found to be defective, what's the probability that it was produced by machine B? Okay, so I'm really not liking the way that they're wording these questions because they should have phrased this using the language of given, right? This is really a conditional probability that they're asking. They want to know the probability that the part came from machine B given that it was defective. Okay. Now, I know this from just a lot of experience, so I'll share that experience with you. If the question has the word if, that is also a clue or keyword that they're asking a conditional probability. Okay, the more traditional word that you're looking for is given, but if you don't see it and you see if, almost always that's going to be a conditional probability. All right, so we need to find the probability of both of those things happening and divide it by the probability of the condition, which is that the part is defective. Okay, now we already know the probability that the part is defective. We just found that in part A, it's 19%. All right, so we'll fill that part in here. Okay, now let's find the probability of both, right? Both meaning it came from machine B and it was defective. Hey, that's this value right here. It's 9%. Okay, so of the 19 total percent of parts that are defective, 9 out of that 19% came from machine B. All right, if we simplify this ratio, 9 out of 19, it's about 47%. It's 47.4. 0.474. Okay. All right, there you go.